The question is, explain the experiment conducted by J J Thomson that led to the discovery of electrons. The answer for this question is J J Thomson's experiment, the discovery of electrons. J J Thomson performed the experiment on cathode rays for the discovery of electron. J J Thomson, a British physicist, conducted a series of experiments in late 19th century that led to the discovery of electron. His experiments involved studying the behavior of cathode rays, which are streams of charged particle emitted from negative electrode, that is cathode, in a vacuum tube. This is the vacuum tube, and we have two metal plates. One is connected to the positive terminal of high voltage battery and another one is connected to the negative terminal of high voltage battery. The plate connected to positive terminal is called as anode, whereas the metal plate connected to negative terminal is called as cathode. Let's understand about the experiment. First, we have a vacuum tube. He used specially designed vacuum tube with a cathode and an anode, and the tube was filled with low pressure gas. Then Thomson applied electric and magnetic field to the cathode rays. The electric field would deflect the rays in one direction while the magnetic field would deflect them in the opposite direction. By carefully measuring the deflection of cathode rays in both electric and magnetic field, Thomson was able to calculate the mass to charge ratio of the particles, and Thomson found that mass to charge ratio of particles in cathode rays was much smaller than any known atom, which led him to conclude that cathode rays were composed of very small negatively charged particles, and he named these particles as electrons. Let's summarize the key findings. First is existence of electrons. Thomson's experiment proved the existence of electrons as fundamental particles of matter. Second is properties of electrons. He determined that electrons have a negative charge and a very small mass compared to atoms. Next is subatomic particles. This discovery marked a significant breakthrough in our understanding of the atom, as it showed that atoms are not indivisible but are composed of smaller subatomic particles.